everyone, welcome back to my channel. It's Nilab and I hope you're all doing good out there with your studies. So in this video we're going to talk about paramagnetic and diamagnetic in a molecule. So let's get started. First, let's review some information about orbitals. Our s orbital can take 2 electrons. We know that p orbital can have only 6, d orbital can take 10, and then f orbital can only take 14 electrons. So we can call them full-filled orbitals because they all have the specific amount of electrons that they needed to be filled in their subshells, in their shells. So let's start with paramagnetic. What is a paramagnetic molecule? So in molecules that have unpaired electrons in their orbital, they're called paramagnetic. One of the most important advantages of molecular orbital theory over Lewis theory or valence bond theory is that molecular orbital theory can account for many experimental observations, and one of those particular observations involves how certain substances interact with magnetic fields. In this case, paramagnetics are all attracted with magnetic field. The reason is that they have unpaired electrons in their shells, so that's why they are attracted with magnetic field. Let's take oxygen as an example. As we see in this periodic table, oxygen has 8 electrons, and the ground state of oxygen is 1s2, 2s2, 2p4, and we have learned that a p orbital needs to have 6 electrons or 3 paired electrons, but here in oxygen it doesn't have. It only has 1 paired electrons, not 3 paired. So we can say that oxygen is a paramagnetic molecule. Next example is bromine. So our bromine has 35 electrons, and the ground state of bromine is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, and 4p5. So in our p orbital, we need to have 6 electrons to be filled, but it doesn't have 6 electrons. It only has 5 electrons. So we can say that bromine is also a paramagnetic molecule because p doesn't have 3 pairs of electrons. Let's move on to diamagnetic. So our diamagnetic molecules are the molecules that all of their electrons are paired in their orbitals. We can take zinc as an example. It has 30 electrons. The ground state of zinc is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10. So as we see here, all our orbitals has their own specific number of electrons, and we don't see any unpaired electrons over here. And in this structure, in this figure, we can see it clearly that all the electrons are paired in zinc. There's no lone electron or no unpaired electron in our configuration configuration state. So we can say that zinc is a diamagnetic molecule and it has all its electrons paired. So another thing that I want you to know is that noble gases are all diamagnetic, and there's no unpaired electrons in our noble gases. They're all paired. We can conclude that our paramagnetic molecules have to have at least 1 unpaired electron in their subshells or in their orbitals, and diamagnetic molecules have to have all their electrons paired that we need, and then we can call them a diamagnetic. Otherwise they are paramagnetic. So I hope you have learned something from this video. If you did, please thumbs up and then subscribe to my channel, and I'll see you in my next video. Thank you so much for watching my video and have a nice day. Bye bye.